sometimes we can draw more than one good Lewis structure. So let's look at sulfur dioxide, SO2. So here we have 3 atoms, and we have to figure out how to connect them. So we'll go for symmetry. We'll put the sulfur in the middle and put an oxygen on each side. So we'll put an oxygen over here, sulfur here, oxygen over there. And then we have to figure out how many electrons are we going to have to mess around with. So stick that down here. We have 2 oxygens. Each oxygen has how many valence electrons? 6. And how many does sulfur have? 6. So we've got 18. We can put 18 dots on our Lewis structure. We have to start out with bonds between these. So there's 2 electrons, 4 electrons, and now we start scattering them about. So 2, 4, 6, 8, 10, 12, 14, 16, 18. I'm short 2 electrons, right? I don't have enough to give this oxygen an octet. This is where we need to make multiple bonds because there's not enough. So when I'm looking for a lone pair to move into a bonding pair, I'd prefer to take it from an atom that does have an octet rather than one that does not. So I'm going to take a lone pair from this sulfur, and because this sulfur is in a good place. So she can afford to share more with oxygen. This oxygen's hurting, not having enough. So we're going to take this pair and share it in between. Stick it in here. This oxygen has an octet, 2, 4, 6, 8. This sulfur has an octet, 2, 4, 6, 8. And now this oxygen has an octet, 2, 4, 6, 8. Good Lewis structure. Any questions? So these atoms are both oxygen, but they are 2 different atoms. Okay, you can have identical twins, but it's 2 people, right? They may look the same, they may act very similar, but they are not the same person. So why does this oxygen have a double bond and this oxygen has a single bond? Why doesn't this oxygen get the double bond? Could we draw that? Of course we could. Let's put the double bond to the oxygen on the left. That will require moving around some of the lone pairs. Now this oxygen has a double bond, has an octet. The sulfur has an octet. This oxygen has an octet. Yeah? Because if we did 2 double bonds, one of the atoms would have too many electrons. But right now, because of sharing, this sulfur has 8. 2, 4, 6, 8. And this oxygen has 8. 2, 4, 6, 8. If I take this pair and share it, this oxygen's okay, but now the sulfur has too many. It has 10 electrons. And we don't want to do that. So which of these is correct? Both. Awesome. Both and neither. What we do is we draw a line between these. The actual structure is more like an average of these 2. These are called resonance structures. They're equally correct. When we examine sulfur dioxide, we find that these 2 bonds are actually identical. There's not a single bond and a double bond. We can determine that. One way is by looking at the length of the bond. The bonds are the same length. It's really more like a 1.5 bond. There are other bonding models that explain how that could happen. Lewis theory doesn't handle it very well. This is the best we can do. So for resonance structures, we draw both possibilities and put a double-headed arrow in between. So it's essentially a hybrid. So if you think about dogs, so here's a German Shepherd, and that looks like a golden retriever? Or a white lab. Let's call it a white lab. Any dog people, what is that? White lab, thank you. So we got a golden retriever, a German Shepherd and a white Labrador. They mate and have puppies. What do the puppies look like? Well, one of the puppies might look like this. It's a hybrid. It's a combination of both parents. This is what the actual structure is like. It's not that this dog flashes between looking like a German Shepherd and a white lab. One day it looks like a German Shepherd, the next day it looks like a white lab, back and forth. That's ridiculous, isn't it? But when we look at the Lewis structures, we could imagine that happening. Oh, it's just flashing back and forth. No, it's an average of both of them. Lewis structure just doesn't have a good way of indicating that, and so we draw both of them with a double-headed arrow. So if this is my husband and this is me, we have 6 hybrid children. And you look at them and they all look alike, and they don't look exactly like either of us because they're a combination, Japanese and Swedish. I say they're half samurai and half Viking. We have good genetic diversity, vigorous stock there, no inbreeding at all. I'm sorry, I digress. So the bonds are equivalent. So this is how we draw them with the double-headed arrow. But we understand that the true structure is an intermediate or a combination, an average, a hybrid of the two things that are drawn. Any questions? So write the Lewis structure for nitrite ion, include resonance structures. So NO2, we're probably going to put the nitrogen in the middle and the oxygens on each side because that'll give us symmetry. And then we look at how many electrons. Each oxygen has 6 valence electrons. How many valence electrons does nitrogen have? 5. And the negative sign, do we add or subtract? We add. So this also has 18 electrons. So I'm going to put single bonds in. Each line represents a pair, 2 electrons. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18. I came up short, so I need to form a double bond. This oxygen has an octet, the nitrogen has an octet, this oxygen does not. So I want to take a lone pair from the nitrogen and share with that oxygen that doesn't have enough. We take the lone pair off and make this into a double bond. I still have 18 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18. This oxygen has an octet, the nitrogen has an octet, and the other oxygen has an octet. To finish this, I should put brackets around it and indicate the charge because it is an ion. Any questions? We're not done yet.
Nitrogen still has 2. Why don't you share with the other oxygen?
Nitrogen still has a lone pair. Why not share with this one? Because we want 8. Yeah. So we want 8 for everybody. So we don't want to share too much. We don't want to not have enough. So that's what we're going to do. So how do we know if there are resonance structures? This one says include resonance structures, so that tells us we should look for them, right? So resonance structures are going to be when you have a multiple bond, a double or a single or a triple bond, and you have to choose 2 of the same element to put it between. So I have to put a double bond between a nitrogen and an oxygen. Do I choose this oxygen or that oxygen? Well, they're equivalent. That's when there's resonance. Draw it with both. There can be 3 or 4 or even more resonance structures. So I'm just going to draw this again, but I'm going to put the double bond on the other side. So now the oxygen on the right only needs 2 lone pairs. The nitrogen still has a lone pair, and this oxygen is going to have 3 lone pairs in order to have an octet. And overall, we've got this. So these are the 2 resonance structures. Just putting the double bond with the other equivalent atom, and then we put double-headed arrow. So you might say, well, isn't this just rotating the molecule? No, it isn't. Because imagine that this is a mother, and she has twin daughters. And this is Susan, and this is Beth. And there's this extra bond between Susan and her mom. Maybe they're like sharing, I don't know, sharing more somethings, cookies or something. And here, there's the extra bond between the mother and Beth. These are both oxygens, but they are different oxygen atoms. Just like twins are not the same person. They may be genetically identical, but they are individual people. If you doubt that, you go find a pair of identical twins and ask them about that, and they'll talk your ear off, I'm sure, because they get treated the same all the time. Any questions?